Hello, my name is Stephen Quigley, and I teach at the University of Pittsburgh. Today, it's my pleasure to introduce you to the pedagogy of basic coding and share my research on OpenFuego, an open source tool designed to help educators easily integrate aspects of coding literacy, computational thinking, and computer science knowledge into the rhetoric and composition classroom. Before I begin, I should say that parts of this presentation were adapted from my recent publication in Kairos, a Journal of Rhetoric, Technology, and Pedagogy, 2022. Though the concept of basic coding might engender visions of students writing code in BASIC, a coding language popular in the 1970s and 80s, it need not, nor should we preclude it. Rather, the term is intended to reference the field of basic writing. In her 1976 article, Diving In, An Introduction to Basic Writing, published in College Composition and Communication, Mina Shaughnessy urged writing instructors to shift the conversation away from what they thought student writers were doing wrong in the writing classroom to what writing instructors should be doing to better address the specific needs of individual student writers. Similarly, basic coding seeks to challenge both our assumptions of what students can do with code and how we might, as educators, creatively incorporate coding literacy, computational thinking, and general computer science knowledge into the curriculum. The origins of basic coding in the rhetoric and composition classroom trace back to the 1990s, a decade that saw a significant increase in computer labs on college campuses, personal computers in the dorm rooms, MOOs, MUDs, the emergence of hypertext markup language, or HTML, and of course, the internet. Educators in our field immediately saw the potential of web coding, especially in that web coding required students to think about both new audiences and new modes of engagement. While these pioneers quickly realized the struggles of working with code in the writing classroom, they also recognized similarities in approaches to teaching web coding and teaching basic writing. Yet, this period and really all of the 1990s was a time of optimism for those working in the field of computers and composition. As Charles Morin described it in his 2002 article in Computers and Composition, the period was, quote, what we have hoped for, end quote. What we have hoped for, and as we all know now, what was lost in the ensuing decades with the advent of Web 2.0 and the rise of techno-corporations like Twitter and Facebook. In the 2000s, our field was still writing about hypertext, but the positionality and practices were increasingly entangled with corporate infrastructures. By the end of the 2000s, scholars like Kristen Arola in a 2010 issue of Computers and Composition lamented the loss of agency in digital composing, adding, quote, today, being a web writer does not mean creating a homepage, and it certainly doesn't mean understanding how servers, the internet, XHTML, and CSS work, unquote. For Arola, the loss of design agency limited a writer's ability to represent themselves in online environments, and thus prevented them from understanding, quote, how design functions to make meaning and produce selves, unquote. Arola, along with other scholars in our field, turned to analysis and critique as a method for engaging design and unpacking the emerging structures of late capitalism. The field was shifting from wondering what we could do with computers to worrying about what computers were doing to us. Still, there were some holdouts. In Lo-Fi Manifesto, published in Kairos in 2008, it's precisely this lack of agency in the design, this distance between Aristotelian knowing, making, and doing, that Carl Stolle argued for the use of a limited set of standardized technologies to direct digital classroom praxis. These limited technologies included teaching standard computing languages such as HTML, CSS, JavaScript, using standardized protocols that allow for cross-platform functionality, open formats, and even running open source operating systems like Linux. We didn't listen to Stolle, perhaps out of convenience, but largely due to our own digital shortcomings, a truth both unfortunate and understandable. We have been born into an unprecedented age where each new decade exponentially compounds the technological advances made in the one prior, and as a result, our field has been forced to continually adapt to these new advancing technologies, each reshaping what it means to write, to be a writer, to be a teacher of writing. In Coding Literacy 2017, Annette V offers a holistic understanding of the role code and coding play in our everyday lives. She argues that whether we know it or not, in this age of ubiquitous computing, we are all already programmers, using our UI to write the quotidian code for the apps and the digital tools that mediate our interaction and movement through the world. Along these lines, V argues that the same code is changing how we think and how we write. As she eloquently puts it, quote, code is writing, but it also underwrites writing, unquote. For these reasons, V urges us to explore the material and socio-cultural implications of what she calls coding literacy, and to invent new possibilities for promoting this literacy in our institutions. While V does not necessarily advocate for programming or writing code in the rhetoric and composition classroom, her literacy framework provides those of us who do a new approach for imagining this pedagogy. Basic Coding asks that we leverage V's material and socio-cultural approach to coding literacy as we invent and implement new practices integrating code into our classrooms. I argue that of all the things we teach in the rhetoric and composition classroom, multimodal communication assignments will provide our best ingress into coding literacy. Yet, in Robinson et al.'s 2019 study of the digital practices of some 328 educators in our field, the words code and coding are not mentioned. Instead, these researchers found that our field relies on the drag-and-drop affordances of Squarespace, Wix, Weebly, and WordPress to provide a comfortable distance from the proprietary code that runs our rhetoric and composition classrooms. OpenFuego, a basic coding tool, was designed in direct response to UI-driven web design tools. This low-floor, high-ceiling, open-source multimodal tool makes code accessible to teachers and students through the use of code templates, rather than teaching students to program or write code from scratch. This method encourages students to work with code, following prompts in the form of HTML comment tags hidden in the code. Code developers use comment tags to label and describe functions for others who may be working in the same document. In this case, comment tags guide the user through all instruction, explaining what specific lines of code do, how the user can add or modify content, and address and explain issues of accessibility, encouraging the user to design and develop their work in a manner both accessible and usable for all audiences. Each template includes an ancillary code bank consisting of code snippets. These embedded snippets provide the same drag-and-drop affordances of visual design web tools, but instead of clean UI, students work directly with the code. The standard CSS design generates a clean, mobile-ready aesthetic, but leaves the user ultimate control over all design choices. OpenFuego provides a range of code templates designed to support the work we already do in the rhetoric and composition classroom. This is important because labor is and always will be a concern when introducing new pedagogies and tools. If we wish to promote basic coding in the rhetoric and composition classroom and across the disciplines, we can't assign more tasks for teachers to do in addition to what they're already doing. Rather, we must identify areas where teachers are already engaging technology and determine which tasks might best incorporate code into the process. As such, OpenFuego provides templates for class icebreakers, project pitches, independent studies, user manuals, course portfolios, professional web pages, and a general-purpose web text generator. Once students have finished creating, they can upload and commit their files to a project repository in GitHub and publish their web text to the internet. Alternatively, students can host their work on a local university server or wherever else they desire. The important point here is that unlike proprietary code tools, students own their own code, and it's clean. Key design components include hidden comment tags, accessibility guides, common CSS stylings, a code repository to aid invention, an integrated information architecture to encourage knowledge and skill transfer, an agile framework allowing contributions and end-user iteration. Most importantly, OpenFuego is free, open source, and MIT licensed. OpenFuego provides an open source solution. The title and all contents may be adapted for any institutional purposes. For example, here at the University of Pittsburgh, students access and use customized templates on PitFuego. If we intend to address the inequalities and inequities in our field, our institutions, and the communities we serve, then all users and groups, especially those excluded by our designs, must, as Adam Banks in his book Race, Rhetoric, and Technology argues, be able to, quote, both change the interfaces of that system and fundamentally change the codes that determine how the system works, unquote. Because a large majority of our users access technology using smartphones, the work of basic coding will require us to reimagine our phones as code editors. While some of my students have completed OpenFuego projects on cell phones, at present, mobile tools and practices must be further developed to improve usability and accessibility for all users. In addition to coding literacy, OpenFuego is designed to promote a number of other pedagogical goals, including computational thinking and general computer science knowledge. Students working with OpenFuego develop confidence working with code. To get the code to do what it should do, or even more than what it does, requires students to not only adopt a ludic affect, but also participate in discourse communities, both in the classroom and remotely on sites like Stack Overflow and CodeFiddle. Students using OpenFuego must think rhetorically about what they are saying and how they are saying it, using code and following design principles. When we combine confidence, community, and rhetorical awareness, we see students realize their agency as designers and makers as they develop their coding literacy. OpenFuego also promotes computational thinking. As students begin to read through the code, they learn to recognize patterns, especially the symbolic logic of tags, syntax classes, and metadata. Once students begin to understand what the code is doing, they can start working from the other direction, decomposing how visual design on a screen might translate into code. Using HTML and CSS requires abstraction, as when students learn to control elements generally in HTML by calling classes and subclasses, and then detailing these elements on a style sheet using CSS. Finally, students must work algorithmically, following specific processes for writing and testing code, using standardized conventions that will, if all goes well, make a web text. Working with OpenFuego also teaches students basic computer science knowledge, beginning with network systems and software, hardware, and protocols required to make a system work. Students quickly learn why file management is essential to this process and how HTML and CSS work together to write and map the nodes that make up a network and generate images we see on our devices. So what's the data say? In tandem with this project, my research has tracked student attitudes towards working with code at the University of Pittsburgh. The data, collected over 2 years in a dozen sections of different composition courses, show that students with no prior coding knowledge can use this tool to significantly enhance their understanding of code and computer science. Moving forward, I'm interested in conducting more research into what happens when students work with basic coding in the rhetoric and composition classroom. Along these same lines, I'm interested in how incorporating code into the classroom changes educators' attitudes and teaching practices. To this end, I've been conducting outreach and workshops, giving tutorials on how to implement basic coding pedagogy using OpenFuego. If you or your department are interested in OpenFuego, feel free to reach out. I'm also interested in your ideas into basic coding, and especially the value of incorporating concepts such as coding literacy, computational thinking, and computer science knowledge into the rhetoric and composition classroom and across disciplines. Thank you for your time.